Okay, problem number 4. What volume will 1.27 moles of helium gas occupy at STP? So, with the two laws that are given on your EOC, you're using the combined gas law or the ideal gas law. On this one, since it says moles in it, we want to use the ideal gas law, which is PV equals nRT. Here is our N. We're trying to find volume. And here's our temperature, and here's our pressure at STP. So we can solve it this way, but there's an easier way. But I'm going to show you how to use the ideal gas law first, and then I'll show you the simple way. Okay, the pressure, when it's standard temperature and pressure, is 1 atmospheres. We're trying to find volume. The N was 1.27 moles. The R, since we're having our pressure in atmospheres, we need our R in atmospheres. So that's going to be 0.0821. And the units are liters times atmospheres over moles Kelvin. Okay, and then we've got to squeeze in our temperature here. We're also multiplying that times 273 K. That should have gone up there. Okay, so my kelvins cancel out because they're on top and bottom. The moles cancel out here because they're on top and bottom. And I'm going to divide both sides by the 1 atmosphere. So those cancel out. 1 atmosphere written on this side. Would cancel out the atmospheres. That leaves us with our volume being liters for a unit. And we're going to take 1.27 times 0.821 times 273. And when you multiply those numbers together, you get 28.46 liters. Okay, so that's the kind of not too complicated, but you know, a lot of math involved. So let me show you how you would do this if you were doing the easier way. Okay, so since this problem says at STP, I'm going to take I can use going from moles to volume, just doing a one-step T-chart. Okay, so I'm going to put 1.27 moles, and that's moles of helium. And so moles was my given unit. I drop it down, and I'm going to put helium here. And I'm trying to find liters for the volume, and so I'm going to put 1 in front of moles, and since it's at STP, I can put 22.4 liters in front of that. If this problem didn't say STP, then I couldn't use a T-chart. So when you multiply those numbers together, you get 28.45 liters. So the decimal places off just a little bit, but you still get the problem done. Okay, and that's how you do that problem.